Good morning, everybody. Welcome to Overcast Cold October Monday morning with your host, me, Dr. White. And remember, this is Chem 1211. All right, let me remind you this week, Monday through Thursday, you should be taking test number one. I like special effects, I'm ambidextrous. But, anyways, it's Silly Monday. But anyways, you should be taking test number one at the testing center. If you're a special needs student, you should bring along a copy or letter from the Center of Access and Accountability. And I think I say that right. I always mess up their name. But anyways, either bring over a printed copy of your letter or have a screenshot on your cell phone. That way you'll get the special needs that's in your letter. All right, now, and let me check. Everybody see test one reminder on your screen? Uh-oh. Thank you, Jenna. All right, now, you can take test one this week, today through Thursday. They're not open on Friday. On Saturday morning, I will go and pick up the test and then I'll grade them. By Sunday, 4 p.m., maybe earlier, I will have your grades posted, scores actually posted for test number one. By that time, I'll also send out individual emails with each points for each answer for test number one. I'm trying to think, is there a way I can get the test back to you? And I haven't figured out a way because the division won't let me put them at the receptionist at HSC. So anyways, another important thing with test number one, remember the last two pages will be important information. Test number one, I highly recommend you go and look on Blackboard in the lecture section to see what information you will be provided. Also, you should be given a periodic table. The green one, like I've been using, except they'll print it on white paper. And if you don't, ask them for it. They should, but still make sure you get one. That's a periodic table. You will need a picture ID, and I highly recommend you bring your own calculator. They have calculators there, but if you're not familiar with that brand, you're going to have problems. That's why I recommend bringing your own. All right, so remember, this week, from today until Thursday, end of the day when the testing center closes, I don't know their hours, you can look it up. You should be taking test number one. Any questions about test number one before I continue? I'll look at the chat. All right, let's get back to gases. Remember last week, I was starting to talk about what's called gas laws. Gas laws are mathematical relationships that are always true. In chemistry and in science, a law is always true. There's no exceptions. I like those special. No exceptions. So we're talking about the gas law, Boyle's law. And Boyle's law, you don't have to remember this part, but you should know P1 times V1 equals P2 times V2. And P and V can be in any units. What does that mean? Everybody see my whiteboard? Thumbs up, people. Boyle's Law. Thank you. P1 is the initial pressure. V1 is the initial volume. P2 is the final pressure. If I can spell it right. Did I tell you I was always first one down in the spelling bee? And if you had one today, I would be too. That just has never been one of my strong suits in life. Chemistry has. All right, P2 is final pressure, V2 is final volume. And this is Boyle's Law. And one of the areas you can apply it to is a cylinder, a piston. And as I mentioned last week, this played an important role in developing steam engines and the gas engine, because in both cases, you have a gas that changes volume and pressure. So let's try a Boyle's Law problem. Yep, 8 points. Hang in there, I'll be through eventually. Finish. All right, let's take a look at this problem. If a balloon has an initial pressure of 852 torr, an initial volume of 38.6 L, L is the abbreviation for liter, which is a measure of volume, then what is the volume of the balloon if the pressure is reduced to 534 torr? So, as I've taught you all semester, by the way, we're in week 9. We've passed halfway point. Wow. But anyways, what are you being asked to find? The volume of the balloon after you make a change, and that's V2. What are you given? Initial pressure, P1 equals 852 torr. Remember, torr is the unit of pressure. You're also given an initial volume, 38.6 38.6 liters. And then you're given, if the pressure is reduced, that means the final pressure, P2. And that is 543 torr. Remember, what I'm going through now will be on quiz 3, not test 1. All right, so once we've done this, we don't have to look up here. Once we've done this, we don't have to look up here, and we won't. Now, if you notice, what are we being given and asked to find? Pressure and volume. As soon as it's only pressure and volume, you know you need to use Boyle's law. P1 times V1 equals P2 times V2. All right, what are we need to find? V2. Oh no, it's not alone on one side. How do we get that alone on one side? Remember, anything divided by itself equals number 1 is gone. So if I take P2 times V2 and divide it by P2, P2 will be gone. And I'll have what I'm trying to solve, V2 alone on one side. However, listen carefully. Whatever you do to one side, you have to do to the other. So I will. Oops, wrong number. All right, so now I have P1 times V1 over P2 equals V2. Now, I like to do this in good habits I don't break, so I won't. I'm going to rewrite this starting with V2. V2 equals P1 times V1 over P2. And all I've done is rewrite this like this. You don't have to, but I like to. And now, since we took the time to do this, I can fill in the values. P1 is 852 torr. V1 is 38.6 liters. And P2 is 543 torr. Now, before I pick up my calculator, before I do that, I'm going to use my good buddy, my good friend, unit analysis. How do you use that now? Well, if you notice, torr divided by torr. And as I said earlier, anything divided by itself equals the number 1. So now the unit torr cancels out, and I'm left with liter. Is that a unit of volume? Yes. And that shows you set it up correctly. And now I will pick up my calculator, clear it, 852 times 38.6, get an answer, divide that by 543. And my calculator gives me this answer. And remember, when you're multiplying, dividing, the number that has the fewest significant figures is the number of significant figures in your answer. And this has 3 significant figures. All non-zero numbers are significant. Same thing here. Dr. Whiteson's 3 significant figure rut, and the bottom 543 is 3 significant figures. So we have to round this off to 3 significant figures. I'll give you a little time. Your turn. Why don't you round that off? Then I will. You want 3 significant figures. All right, time's up. Keep the 6, keep the 0, keep the 5. Those are all significant figures. Remember, 0 after a decimal is significant. We use the 6 to round off. Is that 4 less or 5 higher? It's 5 higher. So I'm going to drop all this, increase the 5 by 1, and the correct answer is 6.06 times 10 to the first liter, or if you wanted to write it, 606 liters. So notice by lowering the pressure, the volume has increased a lot. And this is Boyle's law. All right. Oh, that was fun. Let's do another one. Hang in there while I'm writing this out. All right, let's read this. Let me read it for you in case you can't read my printing. The old days when I would write it, sometimes students couldn't read my writing and I'd read it out, but my printing looks pretty good, I hope. All right, 8 points. The pressure and volume of a piston is 755 torr at 5.666 liters. What happens to the pressure if the volume is decreased to 1.23 times 10 to the minus 1? All right, what I didn't do in the previous problem, but I'll do now. If you notice, you're only dealing with pressure and volume. I'll say that again. If you notice, in this problem, you're only dealing with pressure and volume. And as soon as you see that, you should think Boyle's law, P1 times V1 equals P2 times V2. Remember, P1, V1, initial pressure volume, P2, V2, final pressure, P2, final volume, V2. Now, I'm going to have you help me out. First of all, what are you being asked to find? That's all I'm asking you to figure out. When you do that, give me a thumbs up. Again, all I'm asking you is what are you being asked to find? All right, my turn. We'll do another one. What happens to the pressure? So you're trying to find the pressure after you make a change. That's the final pressure, P2. Now, I'm going to have you try and figure out what's P1, V1, and V2. What are these numbers right here? Your turn. And when you figure out, all I'm asking you to do is figure out what's P1, what's V1, what's V2. P1, initial pressure, V1, initial volume, V2, final volume. How's my checkers shirt looking? I see interesting patterns on my screen monitor. Again, I'm not asking you to solve anything. Just find out what's P1, V1, V2. Thank you, Gianna Williams. We have two Giannas, GW and GJ, and Dr. White and Anna. Thank you, Anna. Thank you, Gianna J. All right, let's do it. P1, initial pressure. Well, they say the pressure and volume of a piston. This is your initial pressure, 755 torr. And this is your initial volume, 5.666 liters. Now, we figured out that we're trying to find what happens to the pressure, what's P2, and what happens after you change the volume. And the volume is decreased to what? 1.23 times 10 to the minus 1 liter. So now we have that. What are we solving for? P2. Oh no, it's not alone on one side. So how do we get P2 alone? We have to get rid of V2. Remember, anything divided by itself equals the number 1. So to get rid of V2, I'm going to divide by V2, this side. Now, whatever you do to one side of an equation, you have to do to the other. So I divide both sides. Now, anything divided by itself cancels out because it's a number 1. So we now have P2 equals P1 times V1 over V2. Now, you don't have to do this, but I like to. I'm going to rewrite this with P2 first. That's just good habits I don't change. And there we have our equation. And since I took the time up here to figure out what is P1, V1, and V2, I can just put them right in. So P1 is 755 torr times V1, 5.666 liters. And V2 is 1.23 times 10 to the minus 1 liter. Now, before I pick up my calculator, I'm going to check my units using unit analysis, a different one than we used before, but it's still your good buddy. Oh, wrong side. Your good friend, unit analysis. And where we're checking the units, analyzing it in this equation. Notice I have liters divided by liters. Anything divided by itself cancels out. And what units am I left with? Torr. Is torr units of pressure? Yes. So now I'll pick up my calculator, clear it. Remember, when you're doing minus, you want the minus sign here, not the one over here, but in your keyboard to do 10 to the minus 1. And I get this number right here. Now, is that the correct answer? Not yet, no. Because when you're doing multiplication division, and on quiz 3, quiz 4, quiz 5, quiz 4 and test 2, all of them will say, please use proper significant figures for any calculated answer, which this is. Now, this is 3 significant figures. All non-zero numbers are significant. This is, 4 significant figures. And this is 3 significant figures. And the question is, how many significant figures should your answer have? I'm going to take a tea break first. In case you're wondering, yes, it's blueberry tea, one of my favorite. And it should be 3 significant figures. When you're doing a multiplication division, the number with the fewest significant figures is how many your answer should be. So your turn. Round this off to 3 significant figures. I'll give you 15 seconds. Go. Bonus time. All right, my turn. How do you round this off to 3 significant figures? Keep the 3, keep the 4, keep the 7. Those are my 3 significant figures. The next number I'll use to round off, I use the double squiggly line to indicate that for me and you too. Is this number 4 or less? 5 or greater? Yes, so I'm going to drop this, increase this by 1. So we have this huge number. The pressure has greatly increased. And let's take a look at this. By the way, I'm going to do some artwork, so be careful. Don't laugh too hard. Don't break a rib laughing. I should mention, my mother was a really good amateur artist. My father was a really good amateur carver, did some beautiful work, so did my mother. That one bit of that talent rubbed off on me. But here we have a cylinder right here, V1, P1. And if you reduce the volume, push the cylinder down, the piston, you'll have a new pressure and volume, V2 and P2. And notice here we would have P2 is 7.55 times 10 squared, and you've gone 100 times higher to 10 to the 4th almost by lowering the volume. Now, one of the things you should always do in my class or any class, but especially mine, is ask the question, why am I learning this stuff? Well, the obvious answer is someone said you have to take chemistry for a prerequisite to get into a program like nursing, or to take another class as a prereq, or to get into school, 4-year college. So that's why you're taking it. Well, why learn this? What good is this in my life? Well, let's take a look at the problem we just did. If you notice, if you have a cylinder, a piston, and there's gas inside, and you lower the volume by pushing the plunger down, the pressure went way up. It got real high. Let's think about that. How many of you have ever filled a bicycle tire with air, a volleyball, a soccer ball, a football? If you've ever done that with the hand pump, give me a thumbs up. No one? Have you ever seen someone do it with a hand pump? All right, thanks. Well, how does a hand pump work? It works by Boyle's law. You have a cylinder, a plunger, you push it down, and the gas is compressed. And when it's compressed like that, and at a certain point, there's a valve at the bottom right here, it lets the air through into your bicycle tire at a higher pressure, and that expands it and inflates it. Now, how many of you have ever seen or gone to a gas station and they have what's called air compressors? And air compressors are used to fill the tires of your car with air. And how does that work? Well, it has the same type of cylinder, but it also has what's called a ballast tank where it can collect and hold high pressure air. And that's how you fill it. If you ever hear one, you'll hear the pump going and it's moving a cylinder back and forth, pulling in air, letting it go out into the ballast tank at a high pressure. So why are you learning Boyle's law? Because it's used in our everyday life. And it's used by engineers to help calculate things like your car engine. Your car engine, let's see if I can find something quick. Does everybody see the internal combustion engine on your screen? Everybody see it? The Wikipedia? Thumbs up, people, help me out. Thank you. All right, now if you look at this picture on the right here is a piston, this is a cylinder. If you have a V6 car, you got 6 of these. I don't anymore, but I used to have a V8 years ago. I had some fast cars. My mother had the fastest car of our family I've ever driven in or drove. That was a V8 with a 429 engine, huge engine, Chevy and super smart. But anyways, this piston goes back and forth, compressing gas, and then it's ignited, which moves the piston down. And that's because part of it is Boyle's law. And they don't have an animation. But anyways, so why are you learning this stuff? Because it's used in our everyday life. If you go to a gas station and see their compressor, by the way, I finally popped for one about a month ago, but because they're harder to find I bought my own air compressor, but there's still in my neighborhood 2 gas stations that still have free air. You don't have to pay money. Many of the gas stations now do and have for a while. All right. Oh, let's do one more of these. I'm going to let you try the harder parts. All right, 8 points. Yep, 8 points. A piston has a pressure and volume of 655 torr, 4.312 liters. What happens to the volume if the pressure is reduced to 303 torr? All right, right here, I want you to find out. Well, first of all, I'll help you out. Notice there's only pressure and volume. As soon as you see that, you should know Boyle's law will help you solve this. P1, initial pressure, V1, initial volume, P2, final pressure, V2, final volume. First of all, what are you being asked to find and what are you given? Your turn. And when you're done, give me a thumbs up, or you can do a thumbs down, or you can go, I don't think there's an emoji. Is there one that goes like this? Is there a rabbit ears emoji? Oh, it's still silly Monday. And all I'm asking you to do now is figure out what are you being asked to find and what are you given in terms of P1, V1, P2, V2. I should get some game show music. You know, when they ask the question, the big question at the end, and people are thinking and you hear the music. Nah, I'd ruin your day and hum some, but I won't ruin your day. When you're done, give me a thumbs up. Thank you, Gianna W. And there's a Gianna J and a Anna K and a KW me. Thank you, Anna. Please be patient. I try and give everybody time to finish this part. All right, my turn. All right, what are you being asked to find? And you see here what happens to the volume. Now, this is after you make a change, so that's the final volume. You're given a piston has a pressure and volume. That's the initial volume. P1 equals 655 torque. The initial volume you're given here, V1 equals 4.312 liters. And what happens to the volume if the pressure is reduced? That means you're going to change the pressure to a new pressure, P2, and that's 303 torque. Now, what are we being asked to solve for? V2. Your turn. I'm going to let you have some fun, and then I'll do it. Why don't put any numbers in, just take P1 times V1 equals P2 times V2 and solve for V2. That means get it alone on one side. Remember, anything divided by itself equals number one, and whatever you do to one side, you have to do to both. So why don't you try and solve for V2? And when you're done, don't forget, thumbs up. Thank you, Anna. Thank you, Gianna W. Thank you, Gianna J. My turn. All right, we figured out we need to solve for V2. Oh no, it's not alone. I have to get rid of P2. How do I get rid of P2 to get V2 alone on one side? I divide by P2, because anything divided by itself is the number one, it's gone. But whatever I do to one side of an equation, I have to do to the other. So I'll divide it. And anything divided by itself equals, it's number one. 1 times V2 is V2. And on this side, I have P1 times V1 over P2. Now, I'm going to do what I like to do. You don't have to, but I'm going to rewrite this. V2 equals P1 times V1 over P2. And I should mention, when you're doing problems like this that are more complex, let the paper do the thinking. Don't try and do this all in your head. Write it out like I'm doing. I found that once I started doing this in college, my scores went really high up. All right. Now, since we took the time to figure out what is P1, V1, P2, I can just fill in those values. P1, 655 torr. V1, 4.312 liters. P2, 303 torr. And before I pick up my calculator, I'm going to use unit analysis to check my units. Notice torr divided by torr, anything divided by itself is gone. So the units, not the number, is gone. And the only unit I have left on top is L, liters. And by the way, that's a volume measurement. So I've set it up correctly. Now I can pick up my calculator, clear it. 655 times 4.312 divided by 303, and I get the following answer. And the question is this correct? No, you should have the same number of proper significant figures in your answer as the number with the lowest significant figures. And this is 3, this is 4 significant figures, and this is 3 significant figures. Remember, 0 confined by non-zero numbers is significant. So which of these numbers is the lowest? 3. So rounding this off to 3, keep the 9, keep the 3, keep the 2. Those are my 3 significant figures. Next number to round off, is that 4 or less? Yes. So I drop it, and the correct answer is 9.32 liters. And that's how you do it. Now, if I look at the time, we've gone a little over into our break. So let's take a 5-minute break, come back at 9:56. And I'm going to get up and stretch. I'll see you in 5. I'm back. All right, let's continue. Now, we're talking about Boyle's law, and that's one of the gas laws. And everybody see Boyle's law on your screen? Thumbs up, people. Thank you. And let's move on. Now, I should remind you that there are practice problems for chapter 11, this chapter, and I'd hold off doing that until you take test number 1, and I would do the practice problems for the area covered on test number 1 before you take it. Also look at my video with the review. That will help you for test number 1. Now, this is quiz number 3 material. So let's move on. We've done our Boyle's Law practice time. All right, now I'm going to turn the switch, click. Will this be on a test to the off position? And this is called Charles' Law. Now, I forgot to mention, or I think I had it here, where Boyle's Law, the temperature is kept constant. Oh, remember the hand pump? We did that. But Charles' Law deals with volume and temperature when the pressure is kept constant. Now, Charles' law, remember the switch is in the click off position. This won't be on a quiz or test of mine. The volume of a sample gas is directly proportional to the Kelvin temperature if the pressure is kept constant. And I have, remember, a balloon left outside in the winter. Now, Charles' law is V1 over T1 equals V2 over T2. V1 initial volume, T1 initial temperature. V2 final volume, T2 final temperature. Now, you can use Charles' law to determine what happens to the volume of a balloon if the temperature changes. Now, if you notice, this is a lot more complex to solve for, say, V2 than we had with Boyle's law. And when I first started teaching 1211 at COD, I put this on a test. I'll be honest, out of a class of 24, usually only one person got that right. Not good. Why? Well, it's complex math, and students had trouble with that. Speaking about trouble with that, let's straighten out everything. And so I stopped putting it on tests. I cover it, but now, if you look at this, temperature for the gas laws is never in Fahrenheit, never in Celsius, centigrade. It's always in Kelvin. Remember, Kelvin K equals degrees C plus 273. By the way, Boyle's law and temperature conversion will be given to you important information, quiz 3. I used to have students have to memorize things like Boyle's law. And when I did Charles' law, I don't anymore. Now, interesting thing, if you've ever seen one of those party balloons and it's fall and it's winter and somebody has it on their balcony or outside, and overnight it gets real cold and it looks like, oh, some of the air got, or nitrogen, helium, because that's what they normally put in those party balloons, escape because it's all shrunk. No, because the temperature went down, the volume's going to go down. And that's part of Charles' law. And as I said, in gas laws, temperature is units in K, Kelvin, Kelvin degrees C plus 273. This will be given to you important information, quiz 3. And this is an old slide where I have, it won't be on test 2 and it won't be on quiz 2. All right, switch is still off. If you read in your book, if you bought the book, there's something called the combined gas law. which uses pressure, volume, and temperature. And mathematically, it's combining Boyle's and Charles' law, P1 V1 over T1 equals, there's a mistake here, equals P2 times V2 over T2. Now, I'm not going to teach this because this can be derived by another law called the ideal gas law, and that I will teach. Now, you've heard me talk about Avogadro's number, 6.02 times 10 to the 23rd. And Avogadro didn't come up with this number, but what he did come up, well, before that number was this relationship of volume and moles that helped really advance the concept of moles. And again, click, the switch is off, and that's V1, initial volume, divided by N1. N is the moles, equals V2, the final volume, divided by the final moles. And the volume of a gas is directly related to the number of moles of gas when temperature and pressure are not changed. And turns out Avogadro's law can be derived by the ideal gas law. So click, switches off. Let's move on. The ideal gas law. Of all the mathematical formulas in chemistry, and I'm talking about mathematical formulas in chemistry, this is my favorite, and that's the ideal gas law. And the ideal gas law is an equation that includes the quantity of gas in a sample, the temperature, the pressure, and the volume of that gas sample. And the ideal gas law is PV equal nRT. Again, the ideal gas law is PV equal nRT. Now, in the past, you would have to memorize this. No longer. I will give you this plus the units, what I have here, in important information, quiz number 3 and test number 2. Let's look at the ideal gas law. P is pressure, and for this to work, it has to be in atmospheres. V is volume. For this to work, the volume has to be in liters. N is the number of moles. And I've never seen a balance or way of determining moles other than you can weigh things. And you learned, hopefully for test number 1 that you're taking this week, that you can convert grams of weight of a sample to moles. And finally, the temperature, T, and that has to be always in Kelvin. And finally, what's this R? R is called the universal gas law constant. And there are different versions of R depending on what units you'd use. Now, for what I use in this class and most chemists use, we're going to use the universal gas law constant, which is a calculated number. And the one we'll use is 0.0821 atmospheres liters per moles Kelvin. And before I used to say memorize this, and no, you're going to be given this, but learn this whole thing. Now, I should point out that the value of R we have here is 3 significant figures. I once found on a website that was reputable, someone had calculated R to, I think it was 15 significant figures. Why you'd have to need that, I don't know, but they thought you did, and they took the time to calculate it that way. But we will use this version of R, 0.0821 atmospheres liters moles K. And it's ideal gas law time. But first, before we do the actual problems, let's think about something. Why are you learning this stuff? Well, as I said earlier, because someone said you had to take Chem 1211, you want to get a good grade because you need it as a prerequisite for another class or to get into a program or a college, four-year college. Well, why learn this? Well, let's take a look. Your car tires are filled with air or nitrogen, a gas. And PV equal nRT tells you a lot about your car tires. Really? Yep, really. So let's take a look at this. PV equal nRT. And what that means is the sum on this side is always equal to the sum on that side. Now, let's think about when it gets super cold here in January, early February in the Chicagoland area in the winter. And by the way, let me be subtle. Can't know this. In the winter, what happens to the temperature? The temperature goes way low, drops. Well, how does this affect your car tires? Well, PV equals nRT. In your car tires, unless you get a flat and then all bets are off, I hope you don't, the volume is constant. The number of moles, N, doesn't change. And the universal gas law constant is a constant, doesn't change. So if the temperature goes down, guess what? The pressure in your tire has to go down. So PV equal nRT tells you if it gets real cold out, you better check your car tire pressure because if the temperature went down, the pressure went down. Now it's time for Dr. White's story. A number of years ago, I lived at an apartment complex in Schaumburg, Treehouse Apartments. I have my own home now, as you can tell. Well, you can't really tell, but I do. And one cold evening, the temperature was a Friday. I remember I got home and the temperature went down to minus 20 degrees Fahrenheit. That's not the wind chill, that's the temperature. I figure, ooh, next day I better get up early, go out and start my car, drive it around, because when the temperature goes down, that also affects your battery of your car. And it was minus 20 or minus 22 overnight, and it was still like minus 10 or minus 12. And I go out to my car in the parking lot, it's outside, and I go look at my tires and oh no, I've got not one, not two, not three, four almost flat tires. And and then that lasted about 3 seconds. Chemist brain clicks in, and I think PV equal nRT. Temperature went down, pressure in my tires went down. I got in my car, and luckily about 2 blocks away was a gas station. This was about 7:30 in the morning. I got up early to do that. And I was doing my tires, filling them up with air. And I looked when I finished, and there are 8 or 9 cars in line waiting for me to finish. So when the temperature in the winter gets very low, PV equal nRT, the ideal gas law says, check your car tires. Now I have a semi-heated garage, semi meaning heat leaks out from my house through the wall. Not much, but enough that my garage doesn't get super cold, but still I keep an eye on my tires in the winter. Now, PV equal nRT also tells you you should check your tires in the summer. And what happens in the summer? Well, the temperature gets really high. Really high. Well, PV equal nRT. In your car tire, the volume is constant, doesn't change. The amount, the moles, N doesn't change. And R is the universal gas law constant. That doesn't change. So what this tells you is if the temperature goes way up, the only thing that will change on this side is the pressure, which has to go way up. So in the summer, when the temperature gets very high, the pressure gets very high. And therefore, you should keep an eye on your car tires. Now, back in, I think it was about 1995, I don't know, some of you probably weren't even alive then. Oh, that's makes me feel old now. Next thing you'll tell me is I'm losing my hair and I've got gray hair and a gray, I do. But anyways, back in 95, we had a horrendous heat wave. I mean, it was bad. For 2 weeks, the daytime temperature stayed above 100 degrees Fahrenheit. It was hot. In fact, sadly, in Chicago, and I think Cook County, the whole Cook County of Chicagoland area, over 600 people died because of the heat. Because of the heat that summer, the governments, city governments throughout the area enacted what we now have for many, many years. When it gets super hot, there are cooling centers in case people who don't have air conditioning or their air conditioning broke can go to those centers to cool and not overheat and have serious health problems like dying. Well, if at that time I was working for a company in Gurnee, not far from Great America, and I had about an hour drive from where I live in Schaumburg to get there, and it was on the toll road. And when you're driving, you'd see in the afternoon coming home a lot of vehicles pulled over, trucks and cars with flat tires, and you saw a piece of rubber on the road. What happened was they didn't check their tires. Temperature went way up, pressure went way up. Think of if you fill a balloon too much, pop. That's what happened. They had blowouts. So when the temperature goes up in the summer, the ideal gas law tells you, guess what? Check your tires, and you may have to let some air out. Otherwise, they'll explode, blowout. So let's look at that again. Something you should know, a practical use, the ideal gas law, PV equal nRT. P is pressure, V is volume, N is moles, R is the universal gas law constant, T is temperature. Now, in the winter, when the temperature drops real cold, PV equal nRT tells you since V, N, and R are constant, the temperature drops, the pressure in your car tire is going to drop. So you may have to add some more air or nitrogen, whatever you're using in your car tire. Now, in the summer, when the temperature gets real hot, increases, T is temperature. Since in PV equal nRT in your car tire, the volume, the amount of moles, and the universal constant R stay the same. So if this is going to be true, PV always equals nRT. If the temperature goes up, the only thing that can change is the pressure. In the summer, the pressure will go up. And that's a practical use of PV equal nRT. Like I said, I remember that winter. Whoa, was it cold that winter. Then another winter a couple of years later, I think it was in 83 or earlier, we had a 2-week spell where the daytime temperature never got above 0 Fahrenheit. Oh, that was cold. All right, let's take a look at the ideal gas law and in a problem. All right, let's have some fun with this. If you burp 0.2, yep, burp. By the way, your burps, if you burp, are mostly carbon dioxide. So if you burp 0.231 grams of CO2 at 750 torr and 31.2 liters, I don't know where that dot came from. Let's get rid of it. Then what is the volume of your burp? But you never thought you'd see Dr. White getting into burps in this class. Well, yeah, I can get into anything. All right, let's take a look at this. What are you being asked to find? Volume of a gas. What are you given? A weight. You're given torr is a pressure. And you're given liters, L is liters, is a oh, no, it's not liters. That's what I had. This should be degrees C. I even fooled myself out. You're given a temperature, 31.2 degrees C. So if we look at this again, you're being asked to find what is the volume of your burp, volume V. You're given a weight of the gas and the identity of the gas, CO2, carbon dioxide. Remember, at 755 torr is a pressure and 31.2 degrees C is a temperature. Now, is anything changing? No. So what are you dealing with? A gas. And therefore, also 15 points. Yes, 15 points, PV equal nRT. So we can do this now, or we can do it later. Let's do it now first. We're trying to find volume V. Well, we've got to get it alone on one side. So remember, anything divided by itself equals the number 1 because it cancels out. So if I want to get rid of the pressure, get V alone, volume, I'll divide by pressure. However, whatever you do to one side, you have to do to the other. So I will. Pressure divided by pressure equals number 1. 1 times V is V equal nRT divided by P. Now, if you look over here, we're given a weight, a pressure in torr, and a temperature in degrees C. Notice pressure has to be in atmospheres. You're never going to see that in a problem. So I was going to be in torr, millimeters of mercury. Now, my gift to you, volume, you'll always calculate in liters or be given it in liters. N is the number of moles. T is the temperature in Kelvin, but you'll never see a thermometer or any temperature measuring device in Kelvin. I haven't. And you're going to have to convert degrees C to Kelvin. You will be given this in quiz number 3 to remind you Kelvin equals degrees C plus 273. You'll also be given way back here so 760 millimeters of mercury equal 1 atmosphere, and that also equals 760 torr. Hold on. So those are conversions we'll need. And like I said, important information for quiz 3, you'll be given this, what you see on your screen, except it won't say learn this. That'll be important information. So now we have all this. We've got some work to do. All right, now N is moles. So we have to go N is moles. But we have a weight and we want to get to moles. Of CO2. So it's time to use our good buddy, our good friend. Whatever we're trying to get to goes on top of that ratio. Whatever we're trying to get rid of goes underneath. And it will say, just like on test 1, you'll be given, well, first of all, let me put up here mole CO2 grams CO2. 1 mole of a compound equals its molecular weight in grams, and the molecular weight is the sum of all atomic weights. So we need the molecular weight of CO2. 1 carbon, 2 oxygen. Now, where do we get those numbers? Well, first of all, I got to open one up. All right, everybody see the periodic table on your screen. You get those numbers from the atomic weights on the periodic table. And here we have for carbon 12.011, for oxygen 15.999. And remember on test number 1, and will also be on quiz 3, it will say, please use all atomic weights, the 3 significant figures. Now, for carbon, that's 12.0. For oxygen, that's 16.0. So let's go back to our calculations. One times 12.0, 12.0, 2 times 16.0 is 32.0. Add them up, 44.0. So I'll now put here 44.0. Notice grams of CO2 cancel out. And now I can pick up my calculator, clear it. and I get the number 5.25 times 10 to the minus third. And notice this is three significant figures. 3, 1 is the exact number, and my calculator gave me three significant figures. So I have n. R, which you will be given, is the universal gas law constant. Zero point 0.0821 atmospheres per liter per mole Kelvin. So I have R, now I need T. T is temperature in Kelvin, and that's degrees C, which is what we're given, plus 273. And here we do the math. When we get 304.2. Now, when you're doing an addition, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures. Now, 273 is an exact number. Therefore, this has one past the decimal. That's why we keep that 0.2. So now we have nRT. We got to get pressure. Now, pressure has to be in atmospheres. And we have in torr. And once again, use your good buddy, your good friend, unit analysis. And we did this earlier last week. Whatever we're trying to get to goes on top of that ratio. Whatever we're trying to get rid of goes underneath. And important information, I'll write it here. You'll be given for this quiz $760 mercury. We don't need that, but 760 torr equal 1 atmosphere. So for every 1 atmosphere, there's 760 torr. Now 1 and 760 are exact numbers. And therefore, torr, three significant figures, our answer should be. Before I pick up my calculator, notice torr divided by torr cancel out. I'm left with atmospheres, so I'm on the right track. And now I'll clear everything. 755 divided by 760. And let's move down here. I get this number, but this is three significant figures. 1 and 760 are exact number. So I round this off to three significant figures. Keep the 9, keep the 9, keep the 3. Use the 4 to round off. Excuse me. And we'll drop it because that's 4 or less. And for the pressure, that's equal to 9.93 times 10 to the minus 1 atmospheres. Are we done? Far from it. We're trying to find out volume. By the way, now you know why this is 15 points. There's a lot of work to do. So we have V equals nRT over P. All I've done is rewritten this. N, which I'll write down here because I need a lot of room, we figured out, let me move my video. And this should be a -3. 5.25 times 10 to the -3rd moles of CO2. R is 0.0821 atmospheres, liters, mole, Kelvin. And temperature, which we calculated here, is 304.2 Kelvin. And then the pressure, which we calculated here, is 9.93 times 10 to the -1 atmosphere. Now, before I pick up my calculator, if we look here, we have moles divided by moles. If you forget about the bottom number here. So moles cancel out. We also have Kelvin divided by Kelvin. Kelvin cancel out. So that means now on top, the only units are atmospheres, liters. And if you divide atmospheres liter by atmospheres, this cancels out. And the only thing we're left with is liter, which is a volume. So now I can pick up my calculator, clear it. Hang in there. Take that, divided by 9.93 times 10 to the -1. And I get 1.32042 times 10 to the -1 liters. And there's two ways of doing this, rounding off at the end or rounding off at each step. I'm an each step person, but I'll calculate it for the quiz and tests I put this on either way. But for now, we'll just do each step. This is 3 significant figures. This is 3 significant figures. This is 4 significant figures. This is 3 significant figures. And when you're doing multiplication division, the number you get should be the same number of significant figures as the answer, as the number, what number you get should have the same number of significant figures as the number you're multiplying dividing, which means we should round that off to 3. So keep the 1, keep the 3, keep the 2, use the 0 to round off. It's 4 or less, drop it. So the correct answer is 1.32 liters. So if you burp a small amount by weight of 0.231 grams of CO2, the volume is this in liters, which is about 132 milliliters. That's going to be a good sized burp, a really good sized burp. Now let's go through this again. If you burp a certain amount of gas, CO2, at a certain pressure, remember torus pressure, and a certain temperature, degrees C is the temperature, then you're being asked what is the volume of your burp. Now, if you notice, if we took the time, we're asked to find volume. We're given a weight, we're given a pressure towards a pressure, G is a weight, and degrees C is temperature. Now, notice none of those values change. As soon as you see in 15 points, but anyways, you know you have to use the ideal gas law, PV equal nRT. We're trying to find volume. Therefore, we're going to solve for volume by getting it alone on one side. To get rid of the pressure, we divide this side by pressure. Whatever you do to one side, you have to do the other. We did. Anything divided by itself equals the number 1, which you see up here. 1 times V is V. So this is our equation we need. Now, N is moles. Well, we're given a weight. So we have to convert grams to moles. And we learned that hopefully for test number 1, which is being given this week at the testing center, and we converted it. Temperature has to be in Kelvin, and you convert degrees K or C to Kelvin using temperature in Kelvin equals degrees C plus 273. We put that in there and we calculated our, and this should have a K there. It doesn't, sorry about that. And finally, pressure here always has to be in atmospheres. And we went from torrs to atmospheres using this definition. 760 torr equal 1 atmosphere. We set this up using our good buddy, our good friend, unit analysis. Now, common mistake students make on this problem is they don't convert pressure, temperature, or weight to the proper units, which is what I've done right here in this column. Go to N moles, temperature in Kelvin, atmospheres, pressure in atmospheres. And once I get those numbers, I come back to my equation here, put them in, do the calculation, and that's how you do it. So you now can tell your friends, guess what? If I know how much you burp, I can calculate the volume of your burp. Don't do that. You'll lose a lot of friends quickly. All right. Now, if I look at the clock, I don't think we have enough time to do another PV equal nRT problem. We'll do more tomorrow. And by the way, tomorrow's lab uses the cards, like a deck of cards, the periodic table cards from the lab kit. And we'll do that tomorrow. Don't forget the lab you did last week is due tomorrow. Uh-oh, hold on 1 second. Huh, all right. Now, I'm going to be turning the switch off for the next couple slides, but let's go through it. There's something called molar mass, and using the ideal gas law and the weight of a known gas, one can calculate the molar mass, how much 1 mole or whatever moles of a gas weighs. And this has been very useful. But we're going to skip that, and I've got to do something. Hang in there. Sorry about that. Once in a while, when I do a lot of writing on the whiteboard, it overwhelms something in my computer. I've got to close the whiteboard. Actually, you know what? I think we only got a minute left. Wow. Time flies when you're having fun with PV going RT, the ideal gas law. All right. I'm going to close up today. Let me remind you, you should be taking test number 1 this week, Monday, Tuesday, Wednesday, or Thursday at the Glen Ellen COD Testing Center. Bring a picture ID, bring your calculator. I will pick up the tests on Saturday because everybody has Monday through Thursday, and Friday they're closed. Otherwise, you'd have part of Friday too. And so I can't pick it up on Friday, but I'll pick it up Saturday morning. And by Sunday, 4 p.m., I will have your test number 1 scores in Blackboard for you to see. And I will email out individual points for each answer on test number 1. And a week from today, I'll go through test number 1 in our class. And with that, I'm done for today. Everybody have a nice rest of the day. Stay warm. It's cold out there. Remember, I now have office hours on tomorrow, Tuesday, and Wednesday from 6 to 7:15. So if you have any questions before you take test number 1 this week, come on by if you need any help. And with that, I'll say, gang gesund. Bye now.